Hi, I'm Sarah Tilley from Curious Maths. I'm a primary maths consultant based in London and I've been in education for over 20 years. This video is all about counting because counting is a really important skill in the maths curriculum and actually a really important skill in everyday life. So if we couldn't count, we wouldn't know how much we have of something or how much we've got left over or how much we need. We wouldn't know how many days to our birthday, what our score is in the maths test, all those types of things. So counting is really important in everyday life, and what I've noticed over the years is, understandably, as the numbers get harder, children find it harder to remember the counting pattern and make some mistakes that sometimes surprise us. So the purpose of this video is to look back at the 5 principles of counting by Gelman and Gallistel and think about how we could use those ideas to help teach counting when it comes to bigger numbers. I hope you find it useful. So before we start, here are some of the skills that children need to be able to count. And as you can see, there's quite a lot of them, and no wonder it's so tricky. So these are the 5 principles of counting, and these were written by Gelman and Gallistel in 1986. Now the first 3 are how to count principles. And number 4 and 5 are what to count principles. And I'm going to be using these ideas to think about how we can go back to some of these basics to help our children be able to count more easily with larger numbers. The one-to-one principle is all about understanding that for every item or thing you count, it has one number name. And we normally model this by pointing to the object and saying the name at the same time. For example, 1, 2, 3, 4, 5. The pointing and touching the number when we say the number name, 1, 2, 3, 4, 5, helps with that understanding that each item has got its own number name. Now in Key Stage 2, obviously we expect children to be able to do this, but when we start doing some skip counting, we may find that children would benefit from counting in 3s by having a manipulative or an image to help them with that one-to-one. 3, 6, 9. And we could use a numerical number line to assist with that. But let's think about the numbers getting even bigger. What about if we were counting in hundreds? Some children, 100, 200, 300, 400, 500, would benefit from having those out with them to help them. And imagine if we were going even further and counting in 20,000s. So we could use place value counters and 20,000, 40,000, 60,000, etc. Now thinking about counting from a different starting point, what about if we were counting from 220? Now I've had to put them on top of each other because of space. But if we were counting in from 220 in tens, some children might really benefit from having a 10 to assist them when they're doing that count. 230. And what if we changed it to counting in ones from here? So we've got 230, 231, 232, 233. So the idea about going back to the one-to-one principle is to think about if you've got any children in your class who, when they're counting out loud, do they need to move or touch the item to help them remember the pattern? The stable order principle, and that's a how to count principle, and it's all about understanding that numbers have a sequential order, and lots of children master this before they even get to school. But in early years and in Key Stage 1, they have lots of extra practice with chanting and singing songs and rhymes and storytelling, and lots of activities based around the counting to help them remember. Now as they get into Key Stage 2, maybe not so much time is spent because we start hearing things like 98, 99, 90, 10, and counting from 1099 straight to 2000. So I recommend doing lots of practice through the boundaries to support that memory retrieval, and also to consider building on this principle with skip counting by using lots of different measures. The cardinal principle is all about the value of a set and knowing the last number you counted is the total. So in early years we would say 1, 2, 3, 4, 5, and we often kind of circle the set to show that it's how many altogether. And we do lots of that sort of thing. So you might say how many now, how many now. And what we find is over time, particularly with numbers up to 3, that children start to subitize. And there are actually two types of subitizing. There's perceptual subitizing and conceptual subitizing. And at this stage, this is perceptual subitizing. Children start to be able to say there are 3 here without having to go 1, 2, 3. But as the numbers get bigger and we start saying how many here, then we are encouraging children to use conceptual subitizing. And what that actually means is the ability to see pairs or sets within larger numbers. So if I was to say to a child how many here, lots of children would see that as 2 lots of 6 and know that that is 12, rather than going 1, 2, 3, 4, etc. Similarly, if I provide these type of manipulatives, lots of children will be able to count and say there are 30 there by counting in tens, in 5s with a tally, or even using dominoes, which are different. So recognising the double 4 there and counting how many altogether from 8. Now when the numbers get a bit larger, children do need still to be asked how many. And if this was all mixed up nicely, children would do a little bit of subitizing, because what they start to do is they start to collect the same ones together. And they can tell me quite quickly there is 220, 1, 2 and 3. And similarly with place value counters. So if I was to ask a child how many are there, what a lot of them would instinctively do is to group them so they can see amounts within. And we would encourage them then to start with the largest amount, so 10,000, 11,000, 12,000, 12,100, 12,200, etc. And we could count it out, finding the value of a set. And what we could then do is get them to put them into a place value counter, into a chart, so that they can actually check to see and write their number underneath to see if that is right. So when we're looking at larger numbers and we're asking children how many, then we do need to give them manipulatives and images and things to actually use to help them become more effective at counting. Because as the numbers get bigger, we need them to develop that numerosity. The abstraction principle is a what to count principle, and it's moving away from simply seeing and touching, and children have to use what they know from the how to count principles, but without having anything in their hands. So abstraction isn't just about chanting out loud, it's actually a little bit more than that. It's about retrieval. So how about trying something like this? So get some 1,000 place value counters and drop them into a pot. And as you drop them in, children listen and count aloud or in their heads. And you can adapt this over time, and you can change the count as you go along. So you could put a 10,000 in and say, now we're counting in tens of thousands, what number are we on? Now we're counting in thousands, what number are we on? Things like that. So you could also make it even more fun by associating some music to different values. Making music and doing maths at the same time, fantastic. So to build on that abstraction idea, you can get them visualising or imagining and then ask them some questions about it. So I've got an example on the slide there which you might like to pause and read through. But the whole idea is getting them to picture in their heads a number. So that might be digits, or it could be place value counters or deans, depending what you've used in class. And getting them to visualise that number and then explain that you're going to be counting in values. So for example, counting in 100. And whilst they're visualising that number, getting them to think about how the number changes and getting them to think about how they can use this to help them when they're counting in values. So just lots of ideas to get them thinking. The final principle is order irrelevance principle, and that is the second of the how to count principles. So it's all about building children up with strategies and ways to count now they have mastered how to count. So the order irrelevance principle is the idea that it doesn't matter what order you count the objects or the things in, the value of the set will always stay the same. And of course in early years, when we start with counting, we do very much line things up in a row and use our one-to-one to make sure that they know how many is in the set. But as they become more confident with counting and to develop their skills, we might give them something like this. Now, we want children to understand it doesn't matter where you start. You could start here and count the pips this way, or you could start here and go up and down and up and down. But we want them to understand that it doesn't really matter which way you do it. They'll always get the same value as long as they count them all. Now, this comes in really useful when we start to ask questions like this. How much here? And children start to notice that we've got a 7 and a 3 that makes 10, plus 4 more, so we must have 14. And if we gave them a bigger pile of Numicon like this, it might be that they notice that they can organise these values into sixes and count how many there are by doing 3 6s. So what we're trying to do here is build up different strategies of counting a set. Now, if we make the numbers a bit bigger, let's say if I gave some children these sorts of numbers. Now again, it doesn't matter. They might start and say, well, actually there's 40 there, and I'm going to add 100. So 140, 240, 340, 440. They might decide to do that first and then add the ones. But it doesn't really matter which way they do it, because the whole point is about making it work for you, because it's a real life skill that you're going to need. Now let's talk about adding money, for example. There's loads of different ways of doing it. So children don't always instinctively go with the largest values. We can see we've got a £2. We don't necessarily organise them this way, but this is all about our sort of teaching and exploring. So which is the easiest way to count these? How can we find how many there are in the most efficient way? So by doing some work on order irrelevance and getting children to explore and wonder about the different ways that you can count, you actually will build their confidence up and give them that kind of believe they can attitude. Those are my ideas on how you can use the 5 principles of counting when starting to count with bigger numbers. I hope you found it useful. Please subscribe to my YouTube channel and check out my other videos on primary maths, and head over to my Facebook page Curious Maths for more fun ideas. Thanks very much for watching.